Dana, Steven, you guys need this? Okay. Come on up. I got extras. Looking, that's how you guys didn't have them. Okay, there you go. Anybody else needing one? Okay. So when we talked about these equations last time, we talked about the idea that if you saw multiple powers of the same function, or you saw different functions, both of those might be signs that factoring had to happen. So when I look at number 12, I think I'm going to do some factoring on number 12, because what's going to tell me that is I've got a sine squared and a sine. Different powers of the same function. And as I look at this, when I see a squared function and a normal function and a constant, I have to kind of think about, all right, this is a trinomial, which means I'm going to think about my trinomial factoring. So I'm going to think about factoring this like it looked like that. Okay, x squared plus 7x plus 6. I'm sorry, I don't have tissues. All right, x squared plus 7x plus 6 equals 0. When my leading coefficient is 1, that's an easier factoring plan, because x squared is just xx, always. And so now I can do factors of 6 that add up to 7. Okay. And hopefully everybody's like, yep, I got you there. 6 times 1 is 6. 6 plus 1 is 7. So 6 and 1 would be my factors. So if you take this back to kind of the trigness of it all, and sometimes this is how I think about it. I'm like, okay, let me just factor it with regular x's, and then I'll flop it back to the trig function. So x squared plus 7x plus 6 would factor into x plus 6, x plus 1. So sine squared theta plus 7 sine theta plus 6 factors into sine theta plus 6, sine theta plus 1. Basically, x is representing the sine theta. Same kind of factoring we've been doing since the beginning of the year, when we did our rational functions in Unit 1B, when we did our polynomial functions in Unit 1A. Okay. We used factoring to come up with wholes and domain values and all those different types of things. Okay, so now we're going to set both of these equal to 0 and come up with whatever solutions. Let me do this real quick. And a really, really common occurrence that's going to happen in these is we're going to probably have one piece that it's likely it's going to go outside our domain. Meaning, when we think about a sine, actually outside our range, our sine values don't get any smaller than -1, and they don't get any bigger than 1. Sine of an angle has to be somewhere between -1 and 1. So for the sine of an angle to equal -6, that's not going to happen. No solution. And if you want to make yourself, those are the only numbers we can consider. That range of values for sine are my only considerations. So one function, one factor in this function equation doesn't yield any solutions. The other factor, which would be that basically the sine would equal -1, okay, I got that. That's a quadrantal. That's right on the edge of my range. That's another one I feel like we do a lot. And so that's the only solution we're going to get. When you do a problem like this for me, I'm going to look for your factoring. I'm going to look for you telling me that this factor doesn't give me any solutions and that this factor gives me 3 pi over 2. If you don't talk about this factor, I am going to assume you didn't know what to do, and so you left it blank. If you know that there is no solution, you need to say it. If you suspect that there's no solution, you might want to say that, and hopefully you're right. If this is a number that's bigger than 1 or smaller than -1, that is what you need to tell me, that this piece does not have a solution. Yes, ma'am. You write no solution for, so this is exactly how I'd want to see it. I want to see it factored, and then I want to see, I thought about this piece, and from this piece, based on this piece, I say no solution. Based on this piece, I've got 3 pi over 2 as a solution. No, I'm writing that down for your notes. Yeah, you can just write no solution. Okay. Yeah. This is just for you for later. Why did we write no solution? Is because -6 is outside of -1 to 1. Okay. Yeah. That's just extra info from notes. All right. Okay. So, like I've said to you before, since we are specifically doing non-calculator questions, there are only so many different combinations I can ask you to do that will give us the possibility of having non-calculator solutions. Oops. Come here, Mr. Screen. There we go. Which means, quite frequently, we will, in the factoring problems, run into at least one factor that doesn't yield any solutions. All right, I want you to try this one yourself. Now, to help yourself, think about factoring it in that form, okay, which is a little trickier. It's a little bit of a trickier factoring when you have a leading coefficient that's not 1. When you start with a 2 or a 3 or something else, you got more thinking to do. Let's see if you can factor that and finish that. Jonathan, did you need a worksheet too? Okay. That's why I got them. Thank you. Okay. I might need to make more, but that's okay. At least try it, factor it. I know you've got Algebra 1 teachers that taught you, and Algebra 2 teachers, either Algebra 1, both Algebra 1, Algebra 2, or just Algebra 2 teachers in this building who spent long hours working with you on factoring last year from their basements and from their houses. Factor by grouping. One way to think about this, 2 times -4 is -8. So factors of -8 that add up to 7. Okay, right. All right, so when we figure out that the factors are 8 and -1, because 8 and -1 will give us the -8, and the reason it has to be a -8 is because you have to consider the 2 and the -4. You have to consider the product of those two things. Okay. What I do with those numbers, this is kind of the trick, is I've got to put them, I can't just throw them in factors. Okay. I can't just throw them in 8 and -1 like I could on the last problem. I have to use them to rewrite the middle and then do a factor by grouping. There are so many different ways you can do this kind of factoring. I honestly, like I said, I keep telling this every time I pull this out for you guys. I'm like, you know, this is one way to do it. This is actually not the way I learned. I learned just to kind of guess and check. So what I would be doing, what I would have done a little differently is I would have started off with just sort of playing around with 2x and x, because I know that's how to get 2x squared. And then I would have fooled around to figure out, like, how am I going to get a 7 with multiplication and adding? If you know that one of the numbers you have to get is 8, that kind of helps you, because if you think, well, if I put a 4 here, that'll give me a positive 8 for the outside, and a -1 there gives me the -1 for the inside, and 8 and -1 make the 7. Okay. That's how I learned to do it. I almost don't know how to slow that down in my head because, like I said, I've just done that forever, but this is one way to slow it down. Once you figure out 8 and -1, another option is rewrite the middle using that, factor by grouping, do 2 groups. They should have to match parentheses. If they don't match parentheses, you're making a mistake. And then the parenthesis piece becomes one factor. The leftover stuff becomes the other factor. Well, I changed it to x to make it easier for me to do the factoring. But now that all the factoring part's over, I got to go back to, wait a minute, this wasn't x, this was cosine. Yeah. And that is the danger of switching it. You got to remember to switch it back. So yeah, some of the algebra, it's like, it's a lot to write with all these cosines. So if you just kind of figure out, like, okay, what would this look like with x's instead of cosine squared and cosine? And once I figure out the factors in x form, I can do my factors in cosine form. All right, so definitely a challenge to get to the factors. If you are struggling with that, I'll be happy to talk to you a little bit individually if we need to. Let's go ahead, everybody, if we can, from the factor position here, solution, solutions, tell me what I'm going to get. And I'm going to do some writing. So one of my factors will say that the cosine of theta equals -4. Because I set both factors equal to 0. And I solve for cosine just like I would solve for x. So my other factor says cosine theta equals 1/2. Talk to me about some solutions. When does the cosine of theta equal -4? Never, right? No solution on this guy. Too small. Too small. Smaller than -1, bigger than 1, no good. Okay? What about this guy? Ooh, and my picture's still on the board. This was actually one of the first thing we thought about. We did the inverse cosine of 1/2. This is the same type of thinking. The cosine of theta equals 1/2. But I can look at the whole unit circle. So my cosine equal to 1/2 at x value of 1/2 is pi/3. Because that's that guy. Okay, pi/3. If I'm doing a positive cosine, what's my other positive cosine quadrant? So what's going to be my other positive cosine angle? Pi/3, but down here. 5 pi/3. Very good. Good job.